This video is a continuation of my videos on the basic derivative rules. So we're going to do a little bit more complicated problems. We're basically combining all of the rules. So example number 11, to find the derivative, we're going to be using the power rule, the sum and difference rules, the constant multiple rule, and the derivative of a constant rule, all together in one problem. So again, we do this term by term. That's the sum and difference rule. That's all that says. And for the first term, negative 9x cubed, we want to use the power rule. So 3 times negative 9 is negative 27. And then we multiply it by x and we reduce the power by 1. In the second term, 2 gets multiplied to the 4. And we have 8 times x to the 2 minus 1, or 1 power. Negative 8x, again, it's the constant multiple rule, or combined with the power rule. And a constant times x is simply going to be the constant. And then the rule for a constant is the derivative of a constant is 0. So we're done. This is the derivative. An example 12. Now we have fractions. No problem. We're just going to combine the rules term by term. So the first term, we're going to bring the exponent 3 down. And we're going to multiply 3 times the negative 1/2, which would be negative 3/2, times x to the 3 minus 1, or second power. The second term, bring the 2 down, multiply it by 2/3, and we have 4/3 times x to the n minus 1 power, which would be just the 1, minus 3/5 x. Well, that's a constant times x, and so that's just going to be the constant. And then finally, 4/7 is a constant, and the derivative of a constant is 0. So once again, we are done. In the next example, we have to do a little bit of rewriting. So first of all, we want to get rid of the radicals, and we also want to get rid of the variables in the denominator. So I'll do this in a couple of steps. So this is going to involve some rewriting of the basic function. The first term, I'm going to rewrite this in 2 steps. I have a 3 in the numerator, and in the denominator, I'm going to write this as 7x to the 1/2 power, minus the second term, I have a 5 in the numerator, and in the denominator, I'm going to rewrite the cube root of x as x to the 1/3 power. And then the third term, everything is in the numerator, but I'm going to rewrite the radical. We have the square root of x squared. Well, that just simplifies to plain old 3. Now, the second part of rewriting this is to bring the variables from the denominator up to the numerator. Now, we do not touch the 7. The 7 stays in the denominator. We're only moving the x to the 1/2 up to the numerator. So it's going to be 3x to the negative 1/2 all over 7. And I'm just going to put the 7 under the 3 to make it look like 3/7, minus 5. We bring the x to the 1/3 up and make it negative, and then the plus 3. Now we have the function written so that we can apply the rules. And again, to apply the rules, we need the variables in the numerator, and we need them to be raised to a power. So the derivative, applying the rules, would be negative 1/2 times 3/7, which is negative 3/14, x, and negative 1/2 minus 1, or minus 2/2, is minus 3/2. Then we have minus 5 times the negative 1/3 would be a positive 5/3, x Negative 1/3 minus 1, or minus 3/3, would be negative 4/3. And then the derivative of a constant is 0. So this is my derivative. However, we're not done yet because we want to rewrite this in the same form that the original problem was in. And so in the original problem, everything was written in radical form. And so we want to write this answer in radical form. And so to do that, we're going to have to change the negative variables back into positive variables and then back into radicals. So I'm going to take the first term, negative 3, and I'm going to move x to the negative 3/2 down into the denominator and make it positive 3/2. In the next term, 5 is in the numerator, and the x to the negative 4/3 is going to go into the denominator along with the 3, and it's going to become x to the positive 4/3. And then the last step would be to rewrite in radical form. And so this is going to be 14 times the square root of x cubed plus 5 over 3 times the cubed root of x to the 4th. So there's a little bit of algebra involved in these. The first two steps were rewriting the original function algebraically. Then the next step was finding the derivative. And then the next two steps were more algebra to get it back into the original form. All right, we have to do the same thing with this one. I would suggest stopping the video, trying this on your own, and then watch what I do and see how it works out. All right, so I am going to rewrite the function as 2 over 3x to the 5/2 power minus 15 over x to the 7/3 power plus 4 x to the 3/2 power. Next step is to get the variables in the numerator. So I'm going to have 2 over 3, and then I'm going to have x to the negative 5/2 in the numerator, minus 15 x to the negative 7/3 in the numerator. And of course, this is just over 1. And then this is already written in the form I want it, so I'll just leave it. Now I can take the derivative. So applying the power rule, negative 5/2 times 2/3, the 2's are going to cancel out, so I end up with a negative 5/3 times x to the negative 5/2 minus 2/2 would be minus 7/2. Negative 15 times a negative 7/3. Well, the 3 cancels with the 15, we get 5, so we're going to have plus 5 times 7 is 35. X negative 7/3 minus 1, or negative 7/3 minus 3/3 is negative 10/3. And then 3/2 times 4 is 12/2, or 6. Get rid of that. 6x to the 3/2 minus 1, or 2/2 would be to the 1/2 power. And then now, so this is the derivative. This is finding the derivative. Now we're going to rewrite the derivative so that it's in the same form as the original problem, which means written with radicals. So first step is to get rid of the negative exponents. So this becomes negative 5 over 3x to the positive 7/2. This becomes 35 over x to the 10/3. And this one is just fine the way it is, 6x to the 1/2. And then finally, the last step would be to write it as a radical. So we would have negative 5 over 3. And so this would be the square root of x to the 7th plus 35 over the cube root of x to the 10th. And then we have 6 times the square root of x. So if any of this is still confusing you, manipulating the negative exponents, manipulating the rational exponents, again, I have videos on the exponent rules, and I have a video on how to switch back and forth between radical form and rational exponent form. You'll want to make sure that you take a look at some of those videos. Okay, the next two problems, or three problems, deal with negative exponents, decimals. And so you're probably going to want to use a calculator to do some of these. And you can use Desmos. That's always a handy calculator to use. Or you could use your cell phone calculator, whatever is easiest for you. So the derivative of this is we're going to take the negative 0.5 times 2.5. Okay, so negative 0.5 times 2.5 is a negative 1.25. And that's x. And a negative 0.5 minus 1 would be a negative 1.5. Then negative 4.2 times a 0.3. So on my calculator, I'm just going to do 4.2 times 0.3. That becomes 1.26 x. And then 0.3 minus 1. Be careful. 0.3 minus 1 is a negative 0.7. So that's a negative 0.7. And then 1.2 times 1.2. 1.2 times 1.2 equals 1.44, and that's going to be a negative 1.44x, and a negative 1.2 minus 1 would be a negative 2.2. And since this was written with negative exponents in it, we can leave this answer with negative exponents. So we're done. In this next example, all we have to do is 0.3 comes out to the front, nothing to multiply, x, and 0.3 minus 1 is a negative 0.7. Now we have a negative 2.3 times a negative 1 would be a positive 2.3 times x. Negative 2.3 minus 1 is negative 3.3. And then finally, 4.2 times 3, just multiplying those together, 4.2 times 3 is 12.6. And so we have 12.6 x 4.2 minus 1 would be 3.2. And since this problem had negative exponents in it, I'll be fine leaving this with negative exponents. And the next one, again, it's some of the same. So I would suggest stopping the video, doing this problem, and then checking to see if you did it the same way that I did it. So the derivative is 1.5 times 2.3, 3.45, and that's negative. And that's x to the 1.5 minus 1 would be 0.5. Now we have a negative times a positive is going to be a negative 0.2 times 4.1. 0.2 times 4.1 is 0.82 times x. So the negative 0.2 minus 1 would be negative 1.2. And then a positive 2.1 times a negative 3.2 would be a negative. And so we have 3.2 times 2.1, and that's 6.72. x to the 2.1 minus 1 is 1.1. And since we had negative exponents in this, once again, I'll leave it with negative exponents. Here's an interesting little problem. We have negative exponents, negative decimal exponents in the denominator. So again, we need to get the variable out of the denominator. So let's rewrite this where all of the variables are in the numerator. So we take the negative exponent of x and bring it up to the numerator and make it positive. So it'll be x to the positive 3.5 minus 0.2 times x to the positive 0.6 plus 1.2 times x to the negative 2.5. And now we can apply our rules. And so 3.5 times 3.5 is 12.25. X to the 3.5 minus 1 would be 2.5. 0.6 times 0.2. 0.2 times 0.6 is equal to 0.12. So that's negative 0.12. And we have 0.6 minus 1 would be negative 0.4. And finally, we have 1.2 times negative 2.5, and that's 3. And so we have a negative 3x to the 2.5 minus 1 would be negative 3.5. Now, this was written with negative exponents in the denominator. I don't think it's going to be necessary to rewrite this, but just for the sake of it, let's do that. Let's rewrite this so it looks a little bit more like the original problem. I'm going to have 12.25 divided by x to the negative 2.5. In the next one, I would minus 0.12 over x to the positive 0.4. And in the last one, I would have minus 3 over x to the 3.5. All right, we've got two more here. Find the derivative of this function. So again, I would take a moment and go through and see how you do on this, and then compare it to what I do. All right, so the first step we want to do is to rewrite the derivative, or rewrite the function. And so this is going to be 3x squared over 7 minus 1 over 4 x to the positive 5. And then this will be, and I'm going to do two things at once here. I'm going to bring the x to the 3/2 that's in the denominator up to the numerator and make it x to the negative 3/2. We can now apply the power rule and all the other rules. 3/7 times 2 is 6/7 x. 1/4 times 5 is 5/4 x to the 4th. 7/2 times a negative 3/2 is a negative 21/4 times x to the negative 3/2 minus 2/2 is negative 5/2. Well, we now need to rewrite it so that we at least, the middle term has a negative exponent, the last term is written in terms of radicals, so let's just go ahead and do that. This would be minus 5 over 4x to the negative 4. And so this then would be minus 21 over 4. Remember, the 4 is in the denominator, the 21 is in the numerator. And this would be the square root of x to the 5th. And that would be our derivative, written in the exact same form as the original problem. Although this derivative is perfectly acceptable for this particular problem. And one more. So again, take a moment, do this one, and then compare it to what I do. All right, rewriting the original function, we will have 1/3, 3 stays in the denominator, remember, and the x to the negative fifth comes up to the numerator, minus 4 over just 1, because there's just a 1 down here. And then we have x squared. And then I'm going to change this to x to the 3/2 power and bring it up to the numerator, 7 over 2, x to the negative 3/2. We can now take the derivative. This becomes 5/3 x to the 4th, minus 2 times 4 is 8x, and then minus, and so we will have negative 21/4 x to the negative 5/2. And then rewriting this, we have, I'm just going to rewrite the radical part of it. I'm going to leave these two the same, 5/3 x to the 4th minus 8x minus 21 over 4 square root of x to the 5th. There's our derivative. Real quick, just a couple new derivative rules that you're going to see in some of the homework problems. And these are really easy. The derivative of the exponential function e to the x. Well, according to this, the derivative of e to the x is e to the x. So the derivative of the function 5e to the x is simply 5 times the derivative of e to the x, which is e to the x. It is its own derivative. And the next one is the derivative of the logarithmic function. And so the derivative of the logarithmic function at log of x is simply 1 over x. So to apply that to this problem, the derivative of 5 times the log of x is simply going to be 5 times the derivative of the log of x, which is 1 over x, which we can then just write as 5 over x. All right, next up are some applications. I'm going to save this for another video because this one's getting a little bit long. So see you in that video.